You are tuned to Iri-e-learning and I am your host, Teacher. In this structure and bonding lesson, we will examine metallic bonding. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to explain metallic bonding, state the physical properties of metals, define the term alloy, distinguish between the hardness of a pure metal and its alloy, state 3 examples of alloys and their uses. Metallic bonding, as the name suggests, involves metal atoms bonding together. If you look to the left of the screen, each gray circle represents a metal atom. The metal atoms are arranged in regular layers and form a giant structure, since the atoms bond in all directions. When metal atoms bond together, the electrons on the last shell of each atom are free to move around. That is, the electrons are delocalized. Note that metal atoms do not achieve a stable electron configuration when they bond. Therefore, metallic bonds are quite different from ionic and covalent bonds, which we learned about in earlier lessons. The metallic structure is described as having positive centers surrounded by a sea or cloud of electrons noted by those red circles with the negative sign in them. The sea of electrons are delocalized, meaning they can move around the structure freely. The positive centers consist of the positive nucleus and inner shells of electrons for all the metal atoms bonding within the structure. The positive centers are also called positive metal ions. Note that the sea or cloud of electrons are the delocalized valence electrons of all the metal atoms in the structure. These delocalized electrons are shared communally, hence forming the sea or cloud of negative charges around the positive centers. The binding force in metallic bonds is the electrostatic force of attraction between the opposite charges, which are the positive centers, and the negative sea of delocalized electrons. Note that the electrostatic force of attraction between the positive centers and the sea of negative electrons makes metallic bonds very strong. The strong electrostatic attraction or metallic bonds pull the metal atoms close together in a fixed position. As a result, metal structures are typically solids at room temperature. However, mercury is the only exception because it is a liquid at room temperature. We will now examine the properties of metals. There are 2 main factors that affect the properties of metals. These include 1, the strength of the metallic bond. And if we remember, metallic bonds are very strong. Secondly, we have the delocalized electrons, and these are the valence electrons that are moving around the entire metal structure. The delocalized electrons actually explain most of the properties of metals. Metals have high melting and boiling points, and this is so because metallic bonds are very strong, and so a great deal of energy is required to break them. Metals are typically excellent conductors of electricity. Remember that anything that has a charge and moves freely can conduct electricity. So the sea of delocalized electrons are actually negative charges that are moving around the structure. Therefore, metals conduct electricity. Metals conduct heat or thermal energy. The sea of freely moving electrons play a very integral role in the conduction of heat. When the delocalized electrons gain heat energy, they move faster, that is, with greater energy around the metal structure, colliding with metal atoms and transferring the heat to them efficiently. As a result, metals are better conductors of heat than other materials. Metals are malleable and ductile. Malleable means that metals can be hammered or rolled into flattened sheets or different shapes, while ductile means metals can be drawn into wires. The metallic structure consists of layers of positive centers or metal atoms that can slide over each other. As a result, the metal can be hammered or rolled into flat sheets or drawn into wires without breaking. When a force is applied to a metal, the layer of positive centers where the force was applied will slide over the other layers, changing the shape of the metal. Metals have luster, that is, they are shiny when cleaned or polished. The metals appear opaque, that is, you can't see through them because the delocalized electrons absorb light. However, when light of any wavelength hits the surface of the metal, the electrons reflect light, giving the metal surface a shiny appearance. Some metal surfaces appear dull because the exposed metal has reacted with gases from the atmosphere. For example, on exposure to air, aluminium loses its sheen over time because it reacts with the oxygen from the air to produce a dull coat of aluminium oxide. Similarly, silverware tarnishes over time due to the formation of a silver sulfide coating. It is important to note that some metals in their pure form are not hard enough to be useful. Aluminium, copper, gold, and iron are a few examples of such metals. So that brings us to the topic alloys. What is an alloy? An alloy is a mixture of two or more metals. Sometimes may include a nonmetal element such as carbon. The structure of an alloy is quite different from that of the pure metal. When an alloy is made, atoms of different sizes are introduced into the structure. This distorts the regular arrangement of the atom layers in the pure metal. Take a look to the illustration to the left of the screen. You will notice that a larger metal atom, this orange circle, has distorted the regular arrangement of the layers in the pure metal. As a result, the distorted arrangement of atoms in the alloy structure cannot easily slide over each other, making the alloy harder than the pure metal. So just take note that the alloy is harder than the pure metal because the layers or the atoms cannot slide over each other easily. Recall from the Unit 2 lesson on types of solutions that alloys are examples of solid-in-solid solutions. Now we will take a look at some examples of alloys. Starting with bronze. To the left of the screen, there is an Olympic bronze medal. Bronze is a mixture of copper and tin. And in terms of the solution mixture, copper is the solvent and tin is the solute. Bronze is commonly used to make sculptures, musical instruments, and medals. Note, these are not the only uses of bronze. We are only listing a few. Next is brass. To the left of the screen, we will see a countertop bell made from brass. Brass is a mixture of copper and zinc. Zinc is typically brittle while copper is too soft, but when mixed, the alloy, brass, is much stronger than the individual pure metals from which it was made. So brass is not too soft, neither is it too brittle. Next, we'll be looking at 3 examples of steel alloys. And the first one is mild steel, which is a mixture of iron and carbon and is the most commonly used type of steel. Mild steel is easy to bend and pull into wires. In other words, mild steel is malleable and ductile. Uses for mild steel include structural steel, that is, it's used in construction, it's used in making signs, automobiles, typically the bodies of the automobile or the vehicle. It's also used in making furniture, fencing, and there are many other uses of mild steel. The second steel alloy we will look at is tool steel, which is made from iron and tungsten. Tool steel is hard, strong, and can withstand very high temperatures, as well as it has very low malleability and ductility. As the name suggests, tool steel is used to make tools, particularly high-speed tools such as drill bits and saw blades. And finally, we're looking at stainless steel. Stainless steel is a mixture of iron and chromium and sometimes nickel. Stainless steel is strong and does not rust easily. As a result, stainless steel is used to make various durable and long-lasting items such as pots and pans, cutlery, refrigerators, dishwashers, kitchen sinks, and surgical equipment. Here are our lesson summary points. Metals are giant structures. Metals consist of regular layers of positive centers surrounded by a sea of delocalized electrons. The atoms within a metallic bond are held together by the electrostatic force of attraction between the positive centers and the negative electrons. Metallic bonds are very strong, causing metals to have very high melting and boiling points. Metals conduct heat and electricity. They are malleable, ductile, and shiny. An alloy is a mixture of two or more metals. Alloys are harder than the pure metals. The metal lattice structure is distorted in alloys. Bronze is a mixture of tin in copper. Brass is a mixture of zinc in copper. Mild steel contains iron and carbon. Tool steel contains iron and tungsten. Stainless steel contains iron and chromium, and sometimes nickel. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. What constitutes the positive centers in a metallic structure? A. The nucleus only. B. The nucleus and sea of delocalized electrons. C. The nucleus and inner lying electron shells. D. The sea of delocalized electrons. The answer is C. The positive centers in a metallic structure includes the nucleus and the inner lying electron shells. Question 2. Complete the sentence. A metallic bond is A. The electrostatic attraction between the positive centers and the negative sea of electrons. B. The attraction of the nucleus for the inner lying electrons. C. Sharing of valence electrons between adjacent atoms. D. The attraction of the nuclei for each other. The answer is A. A metallic bond is the electrostatic attraction between the positive centers and the negative sea of electrons. Question 3. Identify the statement below that is incorrect about pure metals. A. They have giant structures. B. They have a regular arrangement of atoms in layers. C. They have delocalized electrons. D. They have very weak bonds between the atoms. The answer is D, and that statement is incorrect because strong bonds exist between the atoms within a metal. Question 4. Name the property that is affected by the regular arrangement of atom layers within a metal. A. Electrical conductivity. B. Thermal conductivity. C. Luster. D. Malleability and ductility. The answer is D, malleability and ductility. Question 5. Why is an alloy harder than the metals from which it's made? A. Alloys have a larger quantity of atoms. B. Alloys have different size atoms that distort the atom layers, preventing them from sliding. C. Alloys have the same size atoms that form regular layers that can slide over each other. D. Alloys have a thicker layer of delocalized electrons. The answer is B. Alloys have different size atoms that distort the atom layers, preventing them from sliding. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.